Hello, Course 3 students, and welcome to Lesson 3.1 for our Chapter 3. So within this chapter, we are going to be talking about graphs as well as functions. So we did a lot of work this past week and a week prior on talking about ordered pairs, getting ourselves familiar again with our graphs. And so today's lesson, we're talking about ordered pairs. So I just put a picture of an ordered pair on here, remembering that the first letter or the first number is always the x value, and that second number is always the y value. So our objective today is, by the end of it, I can write solutions of equations in two variables as an ordered pair. So writing solutions of equations with two variables, or two variable answers as an ordered pair. And so let's talk a little bit more about our ordered pairs and what that really means. So here are kind of my key ideas. So an ordered pair, or as we see it as x and y, is a pair of numbers that can be used to locate a point on a coordinate plane. So we've talked about how to locate on a coordinate plane. So typically when I have a coordinate plane, I have, here's quadrant 1, 2, 3, 4, going through, okay. Usually I can locate, okay, maybe the dot's right here. But it also means that it is a solution of a two-variable equation can be written as an ordered pair. So for example here is they've given you an equation form. I'm filling this in. So maybe you're given the equation y equals 20 plus 10x. Okay? You have two variables then in theory. You have a y as a variable and you have an x as a variable. And that's just how our coordinate points are, x and y. So they say that you can have two solutions and you can write it as an ordered pair. So for instance, they are saying that the ordered pair 14, 16 is a solution to this equation because if you plug in 14 into x and show it here, oops, I don't know why this one's the blue one. That was a mistake on my end. This one should be the blue version, 160. And then you plug in the 160 for y. So think about it, okay, yeah, 10 times 14 is 140 plus 20 does give me 60. So this is another way we can talk about solutions to equations. Equations that have an x and a y, or they have, sometimes we've seen like m and n. Not a big fan of those ones as much, just because x and y are so common within algebra too, when we get into algebra stuff next year, that it's a little easier to remember my x and y and also know how to then graph it. So let's go ahead and start actually kind of going through some processes. Some of these you can see some examples. So here is an example just like I was talking about with an equation. So we want to determine whether each ordered pair is a solution of this equation. So I want to plug in these values. So remember this first number, if I rewrite out my coordinate point, means x. The second one means y. So I could also put it above it to help me. So what I'm going to do is, this is a lot like substituting. So I'm going to substitute in. So here's my equation again, y equals 3x plus 2. We want to make sure that this is a true statement when I plug these in. So I'm going to plug in 2 for x. I'm going to substitute in 5 for y. Remember, those mean the same thing. So now I'm going to have 5 equals 3 times 2 plus 2. All right, we just have to solve out this side to make sure to see if it does it actually equal. Well, 5 on this side stays 5. 3 times 2 is 6. 6 plus 2. Okay, well, last step. 5 equals 8. Does 5 equal 8? No. This does not make sense. It does not even out. So this is a no. So ultimately, these questions, when you determine whether an ordered pair is a solution, you're just going to tell me yes or no. Is this a solution? So then B. Now we've got 3 and 11. Again, remember the 3 is my x value, my 11 is my y value. Here was my original equation, y equals 3x plus 2. I'm going to plug in the value for y, plug in the value for x, see if it comes up with a true statement. So we're going to put in 11 for y, I'm going to plug in 3 for x, I'm just going to write it as that 11. 3 times 3 is 9, 9 plus 2. 9 plus 2 does give me an 11, and 11 does equal 11. And this is going to be a yes solution. It does. It is a solution to this problem or this equation, okay? So again, yes or no answers on these. Just plug in those values and see, does it work? If it doesn't, it's a no. If it does, it's a yes. So we're going to continue looking at these kind of equations, okay? And being able to find these coordinate points with them. So for the next example, what they want us to do is use the given values to make a table of solutions. So this time they give me the equation. So here's my equation, y equals 8x. They want to know the coordinate point for when x equals 1, 2, 3, and 4. So here's my table that I've already kind of started to set up. What it has is it's going to have, here are my x values, so right away I could plug them in. I got 1, I've got 2, I got 3, I've got 4. Those are the numbers they want me to use for x. I don't know what y is yet, and then we'll be able to figure out our coordinate point. The equation goes as 8x. So what I'm doing is I'm really just doing a big substitution problem. I'm going to substitute in 1 for x, then I'm going to substitute in 2 for x, then I'm going to substitute 3 in for x, then I'm going to substitute 4 in for x. So on this category, I'm just going to show that work. So 8 times 1, 8 times 2, because it's 8x, 8 times 3, 8 times 4. All right, well, 8 times 1 is 8, and that's what my y equals, 8x. So this is going to be my y value, is what I get for the answer of 8x. 8 times 2 is 16, so that's my y, and I continue on. 8 times 3, 24, 8 times 4, 32. Now, if you notice by my graph, I have a column that has x's, I have a column that has y's. So all I'm going to do is match up the x with the y. Going left to right. X is 1. Y is 8. So here's my coordinate point, 1, 8. X is 2, y is 16, 2, 16. X is 3, y is 24, and so on. 4 and 32. So these are all skills we've practiced before. We're just looking at them slightly differently and writing them slightly differently. Okay? How about then, let's start looking at B. Now, I'm not a big fan of B. I should have rewritten this as X and Y, as I mentioned earlier here, because they use M and N. So in this case, we're going to do M and N. I think it's just more important to understand X and Y, but we're going to set it up as similar. So this time we've got this equation. N equals 4m minus 3. This time I've got values for m. They want to use negative values. So on my m category, I'm going to go ahead and start and put them in. -4, -3, -2, and -1. Now I'm going to solve or plug it in. So using my substitution, I'm just going to plug this in for m here. So 4 times -4, and then subtract 3. 4 times -3, then subtract 3. 4 times -2, then subtract 3. 4 times -1, and then subtract 3. Remember, I have to do this multiplication part first. So if you want to, you can put in parentheses here to help you remember that. Because once I solve out this part, that's what n equals. N equals 4m minus 3. So 4 times -4 gives me a -16. -16 minus another 3. So it's going to continue being negative, go further into the negative, so it's going to be -19. How about 4 times negative 3? That's going to give me negative 12. Subtract another 3, continuing into that negative, getting smaller and smaller. It's a lot like saying a negative plus a negative. So negative 12 plus negative 3, which means it keeps negative, and I add the 2. 12 and 3 is 15. Keep it negative. All right, 4 times negative 2, negative 8. Negative 8 minus 3 is negative 11. And 4 times negative 1, which is negative 4, minus 3, which is negative 7. So again, we're going to take our values in this category as best as I can circle, and then this category. And we're going to make a coordinate point over here. So we're going to have the m first, so negative 4, negative 19. We have negative 3, negative 15, negative 2, negative 11, and then negative 1, negative 7. So you're showing me that you plugged in, so basically it's showing me you plugged in negative 4 and you got an answer of negative 17. So that's why we're having those both, so that they can see, oh, I did this number and I got this number. It's kind of like those machine things back when you're younger where it's like, I put in this number and this number came out. What's the operation or what's the rule? That's a lot like what these equations are doing. All right, last example. All right, our last example is talking a little bit something different than we're doing, but it's also important to know how to do some of these. So it says that in most states, the prices of each item is not the total cost. Sales tax must be added. If sales tax is 6%, the equation for the total cost is C equals 1.06p, where p is the price before tax. So we have two questions about figuring out what their sale price would be, or their sales tax would be then after, or their, oh my gosh, the total price after sales tax. So A, how much will Dominic's $160 set of jerseys cost after sales tax? So here's the price, or my P, and all we're going to do is continue with that substitution. So we're going to have C equals 1.06, and instead of P, let's plug in that 160. The units we have been not really using calculators, but for this unit, I'm okay if you want to grab a calculator and solve that out. When I actually get an answer, I get that C equals $169 and I believe 60 cents. Okay, so if I wanted to write it showing those two values, I would say that I plugged in, or that first number was 160, and the number I got out of it was 169.60. So that's why I'm going to show that this is the X in this case. I know that we're using different letters, but this is meaning that I plugged this in. This is the input. This number is the output. That's something else we'll be talking about as we talk about functions, is inputs and outputs. X's are usually inputs, Y's are usually outputs. We can kind of think of those terms if we are stuck on those different kind of letters. So then same kind of thing for this time. This time Alyssa bought a $140 set of jerseys. So I'm going to use the same equation. Times 140. I usually like to show that with my parentheses here. Again, you can grab a calculator if you would like. I'm okay with that this time. $148.40. If I want to actually show in that dollar. So again, if I want to show it as a coordinate point, I inputted 140. I got an output of $148.40. All right, I will continue on with this lesson here with you guys in class. So we'll continue practicing these skills. Let me know if you got questions.